Dr. Chen, this stoichiometry problem has me a bit puzzled. It asks, if 12 grams of magnesium reacts with 20 grams of hydrochloric acid, which reactant runs out first? And what is the maximum amount of magnesium chloride that can be produced? I keep trying to figure out which approach to take first for the limiting reactant part, and then I get stuck thinking about the product, so I'm just going back and forth.
This problem combines two common stoichiometry challenges, Sam: identifying a limiting reactant and then using it to find the maximum product. Many students find the initial comparison tricky because it's not just about which reactant has less mass. To start, what's the very first thing we should always establish when dealing with chemical reactions in stoichiometry?
I think the very first thing we need to do is write out the balanced chemical equation for the reaction, right? That tells us what's happening and what the ratios are between everything.
Yes, Sam, that's absolutely correct. Establishing the balanced chemical equation is the essential first step because it shows us the stoichiometric ratios between reactants and products. What do you think the reactants and products are, and how would you write the balanced equation?
Okay, so magnesium and hydrochloric acid are the reactants. That would mean the products are magnesium chloride and hydrogen gas. So I think the balanced equation would be magnesium plus 2 molecules of hydrochloric acid yields magnesium chloride plus hydrogen gas. Does that look right?
That's exactly right, Sam. Your equation, magnesium plus 2 molecules of hydrochloric acid yields magnesium chloride plus H2, is perfectly balanced. Now that we have the balanced equation, what's the next logical step if we want to figure out which reactant runs out first?
Okay, so after balancing, I think the next step is to convert the mass of each reactant into moles. For magnesium, we have 12 grams, and its molar mass is 24.305 grams per mole. So 12 divided by 24.305 gives me about 0.494 moles of magnesium. Then, for hydrochloric acid, we have 20 grams, and its molar mass is 36.461 grams per mole, so 20 divided by 36.461. I'm getting around 0.655 moles of hydrochloric acid. Is that the right way to start comparing them?
Yes, Sam, you've hit on the crucial next step and performed the calculations correctly. You use the mass to moles conversion, N equals M divided by M, for both reactants. Your calculation for magnesium, 12 grams of magnesium divided by 24.305 grams per mole of magnesium equals 0.494 moles of magnesium, is correct. And for hydrochloric acid, 20 grams of hydrochloric acid divided by 36.461 grams per mole of hydrochloric acid equals 0.548 moles of hydrochloric acid. I just noticed a tiny rounding difference on your hydrochloric acid calculation. It should be 0.548 moles. Now that we have the moles of each reactant, what do we need to consider from our balanced equation to determine which one is limiting?
Okay, so we have the moles of each, 0.494 moles of magnesium and 0.548 moles of hydrochloric acid. The equation says 1 mole of magnesium reacts with 2 moles of hydrochloric acid. So if I just compare these numbers, it looks like we have more hydrochloric acid than magnesium, but we need twice as much hydrochloric acid. So maybe I should divide the moles of hydrochloric acid by 2? That would be 0.548 divided by 2, which is 0.274. Since 0.274 is less than 0.494 moles of magnesium, does that mean magnesium is the limiting reactant?
You're absolutely on the right path by using the stoichiometric ratio to compare the reactants, Sam. Your calculation, 0.548 moles of hydrochloric acid divided by its coefficient of 2, which gives 0.274, is correct. This 0.274 moles represents the amount of magnesium that would be needed to react completely with all the available hydrochloric acid. Now let's think about the comparison. You have 0.494 moles of magnesium, but you only need 0.274 moles to react with all the hydrochloric acid. What does that tell you about whether magnesium or hydrochloric acid will run out first?
Okay, I see. So if I have 0.494 moles of magnesium, but only 0.274 moles of magnesium are needed to react with all the hydrochloric acid, that means I have more magnesium than I need. So the hydrochloric acid will run out first, making hydrochloric acid the limiting reactant. Is that correct?
Excellent, Sam. You've got it exactly right. Since you have more magnesium than is required to react with all the hydrochloric acid will indeed run out first, making it the limiting reactant. That's a key insight for these types of problems. Now that we know hydrochloric acid is the limiting reactant, how do we use that information to calculate the maximum amount of magnesium chloride that can be produced?
All right, since hydrochloric acid is the limiting reactant, we use its moles, 0.548 moles. The balanced equation says that 2 moles of hydrochloric acid produce 1 mole of magnesium chloride. So, I would take 0.548 moles of hydrochloric acid and multiply by the ratio of 1 mole of magnesium chloride over 2 moles of hydrochloric acid. That gives me 0.274 moles of magnesium chloride. Now, to convert that to mass, I need the molar mass of magnesium chloride. Magnesium is about 24.305, and chlorine is 35.453. So 24.305 plus 2 times 35.453 is around 90.0 grams per mole. So 0.274 moles times 90.0 grams per mole would be 24.66 grams of magnesium chloride. Is that the maximum amount?
You've done an excellent job of using the mole ratio from our limiting reactant, hydrochloric acid, to find the moles of magnesium chloride. Your calculation of 0.548 moles of hydrochloric acid times 1 mole of magnesium chloride divided by 2 moles of hydrochloric acid equals 0.274 moles of magnesium chloride is perfectly correct. You also correctly identified that you need the molar mass of magnesium chloride to convert these moles to grams. However, let's take another look at the molar mass calculation for magnesium chloride. Remember to add the atomic masses of 1 magnesium atom and 2 chlorine atoms carefully. Can you recalculate the molar mass for magnesium chloride for me?
Oh, you're right. Let me recalculate that molar mass for magnesium chloride. It's 24.305 for magnesium plus 2 times 35.453 for chlorine. So 24.305 plus 70.906 actually equals 95.211 grams per mole. I must have made a small arithmetic mistake earlier. Thanks for catching that.
Yes, that's exactly right, Sam. The molar mass of magnesium chloride is indeed 24.305 grams per mole, plus 2 times 35.453 grams per mole equals 95.211 grams per mole. Good job catching that arithmetic mistake. Now that you have the correct molar mass and the moles of magnesium chloride, what is the final step to find the maximum amount of magnesium chloride produced?
Okay, so I have 0.274 moles of magnesium chloride and the correct molar mass is 95.211 grams per mole. I'll multiply those together. 0.274 moles times 95.211 grams per mole. That gives me 26.087794 grams, so I'll say about 26.1 grams of magnesium chloride. Is that the final answer for the maximum amount produced?
Your calculation of 0.274 moles times 95.211 grams per mole, which equals 26.087794 grams, is arithmetically correct. Now, thinking back to our initial measurements for magnesium and hydrochloric acid, how many significant figures were in those values, and how does that affect the precision of our final answer?
So the 12 grams of magnesium has 2 significant figures, and for 20 grams of hydrochloric acid, I always get confused with zeros. I think that might only have 1 significant figure since there isn't a decimal point. If that's the case, then our final answer for magnesium chloride should probably also only have 1 significant figure, making it just 20 grams. Is that right?
You're absolutely right about identifying the significant figures for your initial measurements, Sam. 12 grams has 2 significant figures, and crucially, 20 grams without a decimal point indeed has only 1 significant figure. Since the result of multiplication and division should only have as many significant figures as the measured value with the fewest, our final answer must be rounded to just 1 significant figure. However, when you round 26.087794 grams to 1 significant figure, what value do you get?
Okay, so rounding 26.087794 grams to 1 significant figure. If the 2 is the first significant figure, then the 6 next to it means I should round up. So, it would be 30 grams. Is that the right way to round it?
Yes, Sam, you've got it. When rounding 26.087794 grams to 1 significant figure, the 2 is your first significant digit. Since the next digit, 6, is 5 or greater, you round the 2 up to 3 and replace the subsequent digits with zeros to maintain the magnitude, giving you 30 grams. That's the correct application of significant figures based on our initial measurements.
Thanks so much, Dr. Chen. I definitely feel much better about this now. Figuring out that limiting reactant step was tricky for me, and I also learned to be more careful with molar mass and significant figures at the end. I really appreciate your help walking me through it.
You're very welcome, Sam. I'm glad we could work through this together. Your final answer of 30 grams of magnesium chloride is correct. Congratulations, you've solved the problem. To summarize, we balanced the chemical equation, converted the given masses of reactants to moles, used the stoichiometric ratios to identify hydrochloric acid as the limiting reactant, then calculated the moles of magnesium chloride from the limiting reactant, converted that to mass, and finally rounded to the correct number of significant figures.
Thanks so much, Dr. Chen. I definitely feel much better about this now. Figuring out that limiting reactant step was tricky for me, and I also learned to be more careful with molar mass and significant figures at the end. I really appreciate your help walking me through it.